Welcome students. In last period we have seen type conversion. We have started type conversion. Also we have seen type conversion, that is what is meant by user defined conversion and what are the situations where user defined conversion is necessary. So three situations we have seen, that is when expression involves mixed variables. That right hand side is basic data type variable and left hand side is a class. So expression, assignment expression involves right hand side basic and left hand side is a class type. So this is the situation called basic to class. Also right hand side may be object, that is called as a class type, and left hand side may be basic, that is called as a class to basic. Or it may possible that there are two classes, there are two objects are there respectively. So one class is equal to another class. So in last period we have seen basic to class. Today we are going to see class to basic and class to class. So class to basic conversion. Class to basic conversion. Class to basic conversion. Now, class to basic conversion is accomplished by casting operator, as we have seen. Basic to class conversion is accomplished by constructor, where the constructor construct example, here c is equal to 8, you see example. 8 is a basic value that you are trying to assign s, where s is the object. So this type of conversion was accomplished by a constructor. If we call this is the source, this will be the destination. So constructor in destination. Now what about class to basic conversion? Class to basic conversion is accomplished by overloaded casting operator. Overloaded casting operator function. Now question arises, we have seen overload, how to overload the operator. So we have overloaded plus operator, we have overloaded minus. Overloading the operator we have seen. But what exactly a casting operator? Overloading casting operator. So casting operators are nothing but the names of data types. For example, int is the data type, float is a data type. So data type, int, float, it decides the cast of variables. That's why it is called as a data types. Now we will see one program. Class, suppose simple is there, and let us go this side. Class simple, here integer x is there, and inside the public there is a function void put void cout x. Now to this class. So you might be surprising that we have designed the class simple, in which there is one data member in private, but there is no function to initialize the x. And we know that the private data members can be initialized by member of its own class. So this class must have a such function who will initialize x, but we have not defined any such function. We have defined the put function, but what it is doing? It is counting the x. So without initializing, how we are going to display that? Surprising. So you can ask the question, unless until x is initialized by the member function of its own class, how it is possible that cout x can be taken place and what the value will be there in x? Let us come to the next one. While main. Okay. Here, integer L is equal to 8. Now look, we have declared the variable int L, also initialize it to 8, and also we are creating one object simple s. So object is created. Object is created. S. Object s is created, in which there is x function, in which there is a get function. But x is not initialized, you see, because there is no such any such function who will initialize x. Here I will write s l. Okay. Now class to basic. Now class to basic L is equal to s. Look this expression. In last period we have seen s is equal to L. Now basic L. Suppose L is uninitialized. L is uninitialized. Come, change. And S is initialized. Instead of that, suppose get. And here, instead of that, we will initialize x is equal to 8. Y. Now look what the change we have done. Previous L was initialized and x of object S was uninitialized. So that conversion here is L. L is initializing to x. But here we will call now S dot get. What will happen? Get function will execute. It will initialize x is equal to 8. So L is equal to S. Look, S is class type variable. L is int. Now L is equal to S. So as soon as this expression is encountered, compiler searches, is there any overloaded casting operator function? But there is no overloaded casting operator function, and we have seen class to basic conversion is accomplished by overloaded casting operator function. So here we are going to define what the name of casting operator function should be. Name of casting operator function should be data type of left. So int, no parameters. Now, as soon as this expression is encountered, this function will get executed. And as this function is executed, we can say L is equal to S. So what happens if L is equal to S? This function will get executed and return will be taken place. Return X. Now you can ask the question, if it is returning X, here data type must be int, return type must be int, name of the function operator int. Now question arises, as soon as this expression is executed, encounters, yes, we call this function that is operator int and it will return the X. So what will happen? The value of X here only. So it will become 8. Here return value x will available here and yes, and return value of x is we have initialized to 8. So here it becomes 8, and if you take cout L, you will find the output will be 8. Now question arises, here L is not initialized. Simple yes, yes dot get function is executed, x is initialized to 8, L is equal to yes. As soon as this expression is executed, this function will execute, and 8 value will be dropped here, that will be initialized L. So if you take the cout L, there will be 8. So this is a function that is called as a overloaded casting operator function. This is overloaded casting operator function. Now overloaded casting operator in source, whereas in last period basic to class, constructor must be in destination. Now third type we are going to see, that is class to class. Class to class. Class to class. Class to class. How the class to class conversion should be performed? Class to class conversion. Let us suppose there are two classes. Say class rectangular, class rect. Here there are some float values x, y, and there is one more class polar. Class polar, class rectangular, in which here they deliberately we are converting into public. Here float theta radius. Now the expression should be mixed data types. Wide main. Rect R. Now suppose R we have to initialize. So inside here public we are getting the function rect in bracket here the value we will pass 4. So default constructor is not there, actual parameter int. So here you can take the int, no problem, int x1. Actual parameter 4 and 4 formally become integer x suppose, integer y suppose. Y. X is equal to xx, whereas y is equal to yy. What will happen now? 4 and 4 actual parameter formally become xx. So this is initialized. And look here, there is theta and radius. So polar P. Object P is created. Object R is created, also initialized. P belongs to polar, defined but not initialized. Here I am writing P is equal to R. Look at the expression now carefully. R belongs to rectangular, P belongs to polar, both belongs to different class. R consists of x and y, P consists of theta and radius. How it is to be? This is the x, y, x and y. 1, 2, 3, 4. 1, 2, x, 1 2 3 4. Okay, 4 1 2 3 1 2 3 4. So this will be the radius, and you can say that this value point is represented by xy coordinate, whereas this point can be represented by theta and radius. So how to point is represented by xy. Point can be represented by theta and radius. So circle will be like this. Now theta and radius point can be represented by theta and radius point can be represented by x and y also. So here how the x and y can be given to converted to theta and radius. So as soon as this expression is executed, you can have a constructor in source or you can have the casting operator in destination. Casting operator in destination, you can have constructor in source, constructor in destination or casting operator in source. So we will have constructor public. Now constructor will be there, polar. But what the polar? The expression will be like this: P in bracket R. So rect small r, and what it will be? Return. No return type. Constructor never returns. Theta is equal to, theta belongs to, theta is equal to which theta? Say tan theta. So tan theta is equal to x by y. So tan inverse of y by x. So in C++, tan can be displayed as a tan, a function, a tan of y by x. But here r dot y oblique r dot x. Radius, we know that radius is equal to r dot x multiplied by r dot r into x plus, as we know that x square plus y square under root. So under root it can be displayed as SQRT. Radius is equal to square root of what? R dot x multiplied by r dot x. This is r square plus r dot y multiplied by r dot y. So x square plus y square under root, it will give the radius. So P is equal to r. So this constructor will get executed. R will become actual parameter, who is 4 and 4. It will be assigned to theta and radius. And suppose there is this will while C out theta, C out radius. So P dot put. So it will display theta and radius. So here class polar forward definition will be there. Forward declaration class polar. And as we are using SQRT, a tan, hash input, math part must be there, and there must be hash include iostream.h. So This can be taken place. So 3 types of conversions we have seen. What we have required, that also we have seen. So I think today you have got all 3 types of conversion, that is basic to class, class to class, and their situations also. So in next period we will see inheritance. Thank you.